Hello, and thank you for attending second grade's Math Dive in 5 focused on addition and subtraction problem solving. In order to support our understanding with this Math Dive in 5, I ask that for this first task, after we talk about it, please pause the video and with a partner or with your grade level team, depending on who you plan with, you'll see attached there a problem type chart as well as problem scenario cards. I ask that you read each problem scenario and determine which problem scenario matches with the problem type shown on the chart. So for example, we could see the first problem there. That particular problem would be a compare difference unknown problem. So again, pause the video, either download and print or just download and have a conversation about what these scenario cards match up to which each problem type. See you back soon. Okay, so here you could see the progression with our new best standards. First grade students have been exposed to solving real world problems involving situations of adding to, taking from, putting together, and comparing with two whole numbers whose sum was less than or equal to 20. Students apply and communicate their knowledge of the problem types, such as I referenced adding to, taking from, putting together, and comparing with an 100 now. That is what will happen in second grade, and they will also represent their mathematical thinking as they solve 1 and 2 step problems through a progression of CRA, concrete, pictorial, and abstract representations. And you could see that in third grade, they progress to solving 1 and 2 step real world problems involving any of the 4 operations with the whole numbers. So here we see the problem type chart that we worked on within the first task. And this chart shows the different problem types that we as educators need to become more familiar with so that we can utilize the different ways of thinking about addition and subtraction. Often we expose our students to the typical join and separate type of addition and subtraction problems with the result unknown. But as you can see here, there are many, many different types of problems that we should be exposing our students to. Also at the bottom is a link to this chart for you to use as a reference. On this slide, we are presented with two types of compare problems. Both problems are using the same numbers in a different way and could yield different ways of thinking about the relationship between the two numbers. For example, in the first problem, Sean may use the strategy of counting up, even though it is a subtraction problem, whereas the second problem, Sean may count back to solve the problem, also a subtraction problem. So these type of problems are designed, we want to think flexibly about the operations and teach our students to think flexibly about the operations, and that presenting a problem with an unknown path opens our students' mind rather than limiting them to the one operation being taught. Here we see student solutions to the two problems that we discussed on the previous slide. It is clear to see that the student used the number line to think through both problems and represented it here. You can see clearly that in the first number line, the students use the strategy of think addition to solve the problem, whereas the second problem, the students simply subtract it using a number line. As stated on the previous slide, both of these problems are connected because they are either using subtraction or think addition, although both problems are a subtraction problem. We want our students to develop understanding of these strategies, such as using the number line, and think about the model that could be constructed from the mind of the student. When teaching these strategies, we want to teach them for understanding versus procedurally and having our students mimic that particular procedure. So when focusing on addition and subtraction through problem-solving scenarios, We want our students to be using manipulatives initially to develop an understanding of what addition and subtraction is. So we ask that you provide opportunities for your students to directly model the actions that are taking place in the problem. Being that in second grade, you're working with greater numbers, it may be more efficient to use pre-group manipulatives, whereas in the primary grades of kindergarten and first, they may be using counters to model smaller numbers and the actions that are taking place in the problem. This is a very beginning stage, which we would call concrete, where the students are directly modeling the actions and using a manipulative such as a base 10 block to add and subtract within the problem. And moving from a concrete model such as base 10 blocks to a representational model, you'll see here is an example of take diagrams. You'll also often hear them called bar models. So you'll see within this slide that we use those two terms interchangeably. They are both the same strategy. So we want our students to be able to use the bar model to naturally connect to building the equation that matches the particular situation at hand. Bar models are particularly helpful for when we're working with compare problems and also our start and change unknown problems. Again, not every strategy is the most efficient for a particular problem-solving scenario, but we want our students to become fluid with choosing a reliable strategy to help them solve that problem. Another strategy, as we saw earlier in that problem, that students may choose to use is an open number line. This is a great connection to that base 10 model using the base 10 blocks, reinforcing the concept of place value, but it's also supporting our students with getting ready to think about more abstract situations. That's the connection to the abstract where the students would be able to choose a standard algorithm that works for them. So that will help with supporting decomposing numbers and connecting that to using a standard algorithm that works for them, decomposing tens, hundreds, tens, and ones. This problem-solving model is a tool that is actually within one of the skill basics in STEM scopes. This is a great tool for students to use when they're initially learning about the different strategies and using them to solve addition and subtraction problems. It'll help them to develop what strategy may be most efficient to solve a particular problem. This is a great tool for your students to use throughout all of the explorers within this unit. Since we are talking about addition and subtraction problem solvings, I wanted to focus our potential student misconceptions on actually problem solving. One of the things that we see often is that students identify keywords within a problem, and that often we cannot rely on those keywords. We want to think about key concepts. Students will often, if I know that I'm adding or subtracting, I'm just going to do something called number plucking, pull those two numbers out, and use the operation that we've been focused on within the math class. So we really want to focus on that direct modeling where our students are directly modeling the actions that are taking place in the problem so that our students build understanding of the concept of addition and subtraction. We want them to use models such as the base 10 blocks and the number lines, drawing those pictures to help represent the problem to build understanding. Another misconception that we often see with addition and subtraction problem solving is that students only solve one step to a two-step problem. So we want to focus on working to first identify the missing information in the problem. And I know that problem solving model that I referenced a few slides ago would be a great tool to use to help them focus on what is the missing information, what do we need to do, and which operation should we use and strategy to solve that problem. So here we are at the end of this Math Dive in 5, but just to reiterate, we want to, when we're using addition and subtraction with problem solving, we want to ensure that we are starting with the concrete, where students are using, whether it's base 10 blocks or place value discs, whatever they're using to support their thinking. We want to make sure that we provide them experiences with that, and then make the connection from the concrete materials to more of the representational, such as number lines and tape diagrams or bar models, could be called either or. And then lastly, we want our students to derive a standard algorithm that works for them, such as one that we see here, where they are decomposing tens and ones to help them with the subtraction in this particular problem. Thank you for joining me today in second grade's Math Dive in About 5, focused on addition and subtraction problem solving. I hope to see you at our next Math Dive in 5. Have a great day and have fun teaching.